All right, thank you guys for coming to the first Urbit DFW meetup. I've made a presentation for us. It's probably about 20 minutes long, and at the end, if you have any corrections or questions, then feel free to raise your hand, and my lovely girlfriend is operating the slideshow, and we'll go ahead and get started. Urbit is a personal server. That is to say, it's a computer that acts as an agent on your behalf to talk to other computers on the internet. Right now, we all use computers that belong to mega corporations and serve their interests. When you log into Facebook, and talk to your friend, all the real computation and storage is done on servers that belong to Facebook. In a very real sense, they own your data. It's very difficult to avoid at this point. The goal of Urbit is to address the technical issues that led to this state of affairs so that everybody can run and control their own software. There are a lot of projects that have tried to address one or two of the many problems that Urbit tries to solve, but I doubt there is any current project as ambitious or as far-sighted. Urbit is an open source project primarily developed by a company called Salon in San Francisco, and there's another company in Austin that's also working full-time to develop it called Urbit.live. Urbit is famously difficult to describe. This is due to a combination of complexity, an opaque naming scheme, and some genuinely novel ideas and clever recombinations of old ones. It can seem like it leaked into our world from an alternate timeline. Thinking about Urbit requires you to modify a lot of conceptual models that you're used to using to think about computers and the internet. I'm not any kind of expert on these subjects, but I've spent a decent amount of time trying to digest the more technical parts of Urbit, and my goal here is to convey that understanding to you, and to connect the technical decisions and constraints to the problems being solved. And this presentation is aimed at somebody who might have heard of Urbit, but isn't totally sure what it is yet. Or if you're more of an expert in this than me, maybe you can give me some corrections. But to begin, here's a list of questions. What if your computer was deterministic? A minimal, strictly defined mathematical function that, given an event sequence, always ended up in the same state. How would it be different from the computers that we're used to, and what advantages might it have? What would a network of these computers look like? What if that computation was standardized so that an app I write today runs on another arbitrary computer in 10 years, or the computer I'm using now still works when I pass it down to my kids? Why can't I take my social graph with me when I leave Facebook? Why isn't Facebook just a protocol? Why has the internet transformed from a peer-to-peer assemblage into a surveillance panopticon? Why are we doing all our computation on some corporation's mainframe as if it's the 70s while they build dossiers on us? What happened to the dream of using networked computers to liberate individuals? How do you grow social software to internet scale without running into the obstacles produced by conflicting values of different communities? How do we preserve the freedoms of association and speech while still allowing for the enforcement of values within groups? How do you disincentivize spam and bad actors in an open system? As you may guess, some of the goals of Urbit are to answer these questions and challenges in an elegant way. I will give you a cursory overview of the system and talk about more of the ideas that it exists to implement. These problems are very difficult to address within the constraints of the current internet, but Urbit is an entire networked computing stack from scratch. The core thesis of Urbit is that all of these are technically solvable problems, if you approach them at the right scale. I'll try working from the bottom up here and give a cursory overview without getting too bogged down in details. I apologize if this is a little dense, but bear with me and it should go here, and the second half of this isn't as technical. Knock is a Turing complete function. You can think of it as the functional assembly code that underpins the entire Urbit stack. Its formal spec is typically described as small enough to fit on a t-shirt, and it has 12 opcodes, or basic instructions. This is a couple of orders of magnitude smaller than the x86-64 instruction set that your PC uses. Knock is pared down to the minimum elements of what might make up a useful computer. For instance, it defines a single recursive data type, a binary tree of integers, and its only arithmetic operator is increment. But a combinator whose only arithmetic operator as increment sounds unusable as a computer. How do you subtract, for instance? As you may know, if your computer can increment, you can derive all the rest of the math that you'd like to out of that operation. For instance, decrementing x by incrementing up to x minus 1. This is extremely inefficient, but Urbit has a cool hack for this. The standard library has all the operations you would expect implemented as jets, written in optimized C, which manipulate values in a formally equivalent manner to a specification written in Nock. That is to say, if you ran a very, very slow version of your Urbit that didn't have jets and did all its math the hard way, but otherwise had the same inputs, the state would end up identical to the jetted version. Nock is virtualized with an interpreter programmed in C called vir. Vir sits between your Urbit and your computer, handing over keyboard and packet inputs to your Urbit and outputs back to your Unix computer to be displayed in its terminal or sent off through its network interface. Right now, Urbit runs as a Unix process, but one can imagine Urbit on hardware meant to run Nock and jets directly. For now, vir is what runs your Urbit on your MacBook or VPS. Hoon is the system programming language for Urbit, the Urbit operating system. Hoon is strongly typed and a functional higher level language that compiles to Nock. It's effectively a collection of Nock macros. Expressions are denoted with runes, which are digraphs of ASCII special characters. Hoon code is made up of these expressions, and as a result, it can be kind of scary to look at, but it's not as bad as it looks. Arvo is the Urbit operating system. It has a minimal kernel, which is only around 600 lines of code, plus some kernel modules called vanes. Arvo's vanes handle the networking, apps, a web server, a version-controlled file system, etc. Your Urbit instance's Arvo begins with a blank slate, then processes any events, packets, or keystrokes, writes them to a log, and outputs its effects, producing new events and its new state. If you play back this log, your Urbit will end up in an identical state. Urbit is deterministic. Your Urbit state is one giant binary tree that is modified by an event log. Nock takes your state and some new event, applies the event to the state, and outputs the new state and a list of effects. Arvo orchestrates events between vanes. The Urbit network protocol and kernel module is called AIMS. AIMS is peer-to-peer and encrypted and runs over UDP. It has a global immutable namespace. An instance's name is permanent, and it's both an identity and a routing address. Urbit's address space is 128-bit, just like IPv6. The total number of addresses, or ships, is effectively unlimited. However, Urbit's address space is also partitioned into classes with different privileges. 8-bit address ships are called galaxies, which are core infrastructure nodes that sign software updates. Underneath galaxies are stars, 16-bit address ships that act as routing infrastructure. Beneath stars are planets, which are ships meant for individual humans. Planet addresses are 32-bit, like IPv4, so there's about 4.2 billion of them. Galaxies issue stars, and stars issue planets. Urbit uses a base 256 phonemic scheme for pronounceable numbers. Galaxies have single-syllable names, like Zod. Stars have two-syllable names, like Marzod. And planets have two-syllable names, hyphenated, like Dalsum Simred, or like these examples. I guess I took the examples out, I'm sorry. This is your identity. Think of it as a combination IP and email address. The words are human memorable, and they sound like cool sci-fi names. But how do you own these names? Urbit's public key infrastructure is a set of Ethereum contracts collectively called Azimuth. Azimuth acts as an ownership registry for ships and a consensus mechanism for network governance. If you receive a ship, your proof of ownership is an ERC 721 token, which is an Ethereum standard for non-fungible tokens. You own this token like you own Bitcoin. As long as you have the master key, then it belongs to you forever. Azimuth technically exists outside of Urbit as a general purpose PKI. Urbit just uses it as a source of truth. If you dislike Ethereum for political or technical reasons, keep in mind that it's not necessarily a permanent or intrinsic part of how Urbit works. It's just the current scheme, though in my opinion, it's a pretty elegant one. Urbit has some very strong opinions and some design decisions that might not make immediate sense. This is a system meant to replace the internet that we've spent half a century building and needs some really compelling wins to be serious. But why make a computer with such a minimal core so that you can freeze it and standardize it? A basic idea underlying the design of Urbit is that many of the problems we have today with the way networked computers work is that the technologies composing them accrued in layers atop each other in ways that produce unforeseen conflicts. We have a million identity systems because each layer reinvents everything in the layers below it in mutually inoperable ways. A universal identity system, a secure peer-to-peer networking stack, transparent to the software using it, and key management and cryptocurrency management baked into the core allows for developers to offload these problems to the operating system without worrying about re-implementing them at the app level and fretting over security, dependencies, translating data between layers, etc. These features are basic traits of the platform available to all software on the system to use. Urbit approaches the problem of cascading system complexity by introducing a hard brake on the core components called Kelvin versioning. Instead of incrementing version numbers, the versions count down to absolute zero. This is a knock and hoon, the very basic elements of Urbit. So instead of incrementing up, they decrement down to zero. And once they get to zero, then they're stuck there forever. They can't be changed. So the idea is that you need to make sure that these are working towards a minimal and perfect state. Knock is at 4 Kelvin at the moment, so 4 revisions from being 0, and Hoon is around 150. This is meant to ensure future interoperability and compatibility, which is one of the most technically ambitious parts of Urbit. This is a system designed so that your kids can execute code that you write today on their future computers, or even boot up your entire ship after an arbitrary amount of time offline or on different hardware. Knock's frozen status means everything above it can be upgraded on the fly, including live upgrades of the kernel, and ensures architectural compatibility forever. I should mention that Urbit's codebase is also much more compact than the computers that you use every day. The entire Urbit stack is somewhere around 50,000 lines of code, and the Linux kernel alone is like 12 to 15 million. Standardization also allows for commoditization. Any computer that can run an Urbit can run any other Urbit and all its software. The platform is an open standard which allows commodity providers to compete over performance without users being locked in or out by proprietary changes or interoperability problems. In practice, this will look something like Urbit hosts running your instance on their hardware for a fee, but you being able to download your instance and all your data to run on another provider or even on your personal computer if you decide to do so. It can also look like hardware implementations of Knock and Urbit native computers manufactured by anybody who would want to, like PC clones. As you're probably aware, the internet of today is built on top of the client-server model. You want to connect to other computers, but you don't or can't leave your computer on all the time, so you offload that duty onto dedicated servers that are run by somebody else. This model grew out of the time-sharing mainframes of yesteryear, and it has served us well, but the limitations have become clear. He who runs the server owns the data. Google runs excellent email servers, and Facebook is fabulous at showing you pictures of the people that you've dated, but it's 2020 and I don't want to be spied on anymore, so why don't we just run this stuff ourselves? First, it's hard, and second, network effects. Running a personal server today is technically possible. You can rent a VPS, set up and maintain an email server, throw a Mastodon instance on it, connect a bunch of chat services, and so forth, but it sucks and it's a huge pain to maintain and troubleshoot. Even worse, you have to be significantly more technically inclined than average to get that far. There's a reason that almost nobody does this. Unix is industrial machinery. Urbit is meant for individuals. Your Urbit is intended to be manageable like an iPhone through a simple user interface that allows you to configure the software on it without having to touch a command line, though it's there if you prefer. Unlike an iPhone, it's open source and extensible and will likely develop an ecosystem of competing interfaces. Today, the interface is called Landscape, and it's a minimal and attractive web UI that you control via your browser, though I know they're launching, I think it's a native like Unix and Mac app later this year. Network effects, on the other hand, are a tricky thing to overcome. Why should we be confident that Urbit will be preferable to Facebook? Why would anyone use a hypothetical Twitter-like service on Urbit instead of the actually existing Twitter, or an alternative like Mastodon? Because these things are not mutually exclusive. Urbit is a computer, not just a social network. Existing networks and services have APIs that allow you to access them via third-party clients. Urbit is a general-purpose computer that you can straightforwardly program to scrape, display, and store data. So why not program your Urbit to scrape all your feeds and messages in one place? Because Urbit is an entire computing platform, every piece of functional utility added to it by software increases the network effect of Urbit. Once enough people are using Urbit for whatever disparate purposes they desire, be it running a Bitcoin trading bot or collated Twitter feeds, They will all find themselves on a decentralized network with universal identity and basic messaging utilities. When you and your friends get hooked into some Urbit functionality or another, the external megacorp services are redundant, so why bother? Urbit's model is everyone running their own server. A hypothetical Usenet-like service on Urbit is an app you install that communicates with your friends' Urbits, which are also running the app. Existing social platforms can be conceived of as relatively simple sets of rules for displaying content, comments, and messages. The hard part is getting everybody in one place, which Urbit's identity and network layers provide for anything built on top of it. It's exciting to imagine the possibilities for rapid experimentation that it makes possible. Urbit presents itself as a critique of the internet as it works today. This isn't purely on technical grounds, but also a vision of a more pro-social internet. The legacy internet was taken over quickly by spammers and hackers. It was designed originally to trust anybody by default. If a person sends you mean emails or a remote code exploit, there's little you can do in response. IP addresses change and email accounts are free and unlimited. Urbit's solution to this is finite address space. I mentioned earlier that there are 4.2 billion planets or addresses meant for humans. Your proof of ownership of your address is a cryptographic token. Right now, these sell for about $20, though the price is ultimately determined by the market. However, the fact that they cost money is half of the solution. The other half is that infrastructure nodes can blacklist bad actors. If it costs $10 or $20 to get an Urbit identity, and you start spamming or abusing people, people may ask the operators of the routing nodes above you to stop routing your traffic. The cost of a planet is ideally cheap enough to not be a burden, but expensive enough that you can't make up the cost from spamming. One can also imagine reputation systems where people individually set rules to automatically block crowdsourced lists of known bad actors. I should note that this system is theoretical, but Urbit is designed to make that kind of thing easy to do, but right now it's small enough that everybody is nice to each other. To briefly recap the design of the network, at the top of the routing hierarchy are galaxies, which sign software updates for all the ships below them and issue stars. A star is expected to perform peer discovery and NAT traversal for the planets beneath it. Stars can issue planets, which are meant for people. The connections your server makes with your friends are directly peer-to-peer where possible, and mediated by a star when it isn't. An important qualification to understand here is that all traffic on Urbit's network is encrypted. Your host star tells you where to send the packets or gets them through the firewall for you, but nobody but the recipient can read them. A simple illustration to understand the routing is you buy a planet from a star, your planet is up and running, and you want to talk to your friend's planet. So your planet asks your star for its IP address, the star asks its galaxy, galaxy asks your friend's galaxy, and that asks your friend's star, and then it comes back the same way, and then you're talking directly with your friend. I'm not sure if that's exactly how it works, but it's something like that. The star above you is called your sponsor. I described how stars could block abusive Urbits from reaching other ships, but that runs both ways. If your star is unfair or malicious, or you just don't like the guy running it, your planet can escape to another star if it'll have you. Stars provide services to planets, and in the long run, they'll probably be mostly operated as businesses, and it's generally a good idea to keep your customers happy. This is a system of voluntary relations. Your star has to like you enough to route your traffic, and you have to like him enough to trust his services and potentially pay him. This creates pressure on both sides to maintain good behavior, and gives a release valve for irreconcilable differences. The sponsor relationship also applies between stars and galaxies. In the long run, this allows for the network to fragment gracefully if it needs to. One of the major development milestones coming up in 2020 is the integration of native Bitcoin and Ethereum support into the Urbit kernel. This is basic wallet support, and API calls for full nodes. But big things have small beginnings. What new possibilities are opened up by having secure digital identities and simple system calls for trustless money? Here's an easy example. Write a program that watches for Bitcoin transactions to a wallet you designate, grants access permissions to media in your Urbit file system for the Urbit IDs associated with the senders, then sends them a message. You now have a decentralized Patreon. This is a bit of a personal angle, but I'm very attached to the aesthetics and design that Talon has brought to bear on this project. An example is the sigil system. In the same way that Pat P converts routing addresses into pronounceable names, like the ship names that sound like alien names, Sigils convert those names into visual symbols that you can easily recognize, and you kind of use them as an avatar on the network. They look kind of alien and mysterious. My girlfriend gave me a painting of mine that I put above my computer. All of this aims at a terminal goal of taking away the necessity of having other people's servers between you and your friends and family. When Urbit conquers the world, your digital life will be fully contained on a device you control, running on an open standard computing model. All your traffic will be private and encrypted, and all traffic meant for you will be addressed to you personally. You will easily experiment with new social platforms with your friends, which will simply be protocol exchanges between your devices and theirs, and you won't be beholden to or spied on by the Googles of the world. Conflicts will be mediated within the groups you belong to instead of from above. Your home Internet of Things devices will run child chips issued by your planet and be entirely under your control. You will be able to run the devices orchestrating your social and financial data online in high-assurance data centers or on your own PC. More than anything, your computer and data will belong to you in a way that it simply cannot today. There's a good deal I've skipped over and a few things that I've undoubtedly got a little wrong in this already long presentation, but I hope you find this as exciting as I do. Urbit is young but moving fast. There's plenty to dip your feet into if you're interested in this. You can read the documentation. It's significantly more clear and robust than when I first tried to learn about this a few years ago. It's much easier now. There's a huge amount of stuff to read on the website, and if nothing else, you can look through the glossary, which has just a list of the many terms that it uses, which can be kind of off-putting or throw you off at first because it's a lot of stuff. But I promise it makes sense if you read it enough. One of the hurdles to learning about this is the jargon, but everything is on the website. And there's a blog with some really great posts from the last couple of months that talk about the technical decisions that led to Urbit being designed the way it was. And there's also a white paper somewhere on the website that's like a very dense academic kind of outline of how it was initially conceived of, I guess. You can hang out in Urbit Help, which is the de facto chat room, and it's hosted on Urbit on the star Dopsod. And everybody is very nice there. It's meant to be kind of a general technical discussion, but it's also just kind of a general chat room for Urbit enthusiasts. Learning to program with Hoon is probably the single best thing you can do to understand how things work under the hood, if you're inclined. You can do this yourself by reading documentation and asking questions in the chat room, but you may benefit from structure if you're like me. Salon organizes informal beginner and advanced Hoon school sessions, and you can sign up on the wait list on the website. Hoon is pretty weird, especially if you don't have any experience with functional programming, but don't let me saying that discourage you. I completed the 101 course with almost no programming experience. I won't pretend it was a piece of cake, but it probably took about 5 to 10 hours a week. There are also meetup groups all over the world. This one's Copenhagen. If you're interested in helping me organize or promote this one, or you want to present at an Urbit meetup, please feel free to talk to me. And there's also a grant program, and Talon incentivizes development of the software by community members and these meetups by granting address space to people. And for instance, the Bitcoin support that's being integrated into Urbit was developed by a community member who's rewarded with address space. And so it's worth taking a look. And that's the end of my presentation. And my name on the network is sitful-hatred, hat red. So if you want to send me a message on there, I'd be happy to chat. And thank you.